So, now see the next chapter, that is chapter 4, moving charges and magnetism. So, we have done about electrostatics and electric current. So, see here, when the electric charges are in motion, they constitute electric current. So, we have done in the electrical circuits the direction of the current and the motion of the charges. So, now see here, whenever there is a current carrying conductor, it has magnetic field around it, and magnetic field is represented by this capital B, and it is a vector quantity, and its SI unit is Tesla, and that is represented by capital T here. So, see here, when a current carrying conductor is like this, it means current is coming out of the plane of the paper. So, we have to give the direction of the magnetic field lines in this case. So, hold the current carrying conductor by the right hand, and this direction of the curling finger are showing the direction of magnetic field lines. So, the current is going up. So, these circles, concentric circles are here like this, they are in anti-clockwise. If the current is coming downward, so by the right hand thumb rule, we can give here the direction of the magnetic field is here like this type of, that is a clockwise. So, we can take here in this way. And if you keep here the magnetic compass nearby the current carrying wire, you can see its deflection. It means there is magnetic field around the current carrying conductor. So, we can also go, if the suppose current is flowing in anti-clockwise direction, this is the loop you have drawn, and current is flowing in anti-clockwise direction. We can take the another loop where the current is flowing in the clockwise direction. If the current is flowing in the anti-clockwise direction, then magnetic field inside the loop or at the center of the loop is here the perpendicular to the plane outward, or you can say the magnetic field is in the direction of the perpendicular, which is emerging out of the plane of the paper. So, that is represented by dotted dot here. It means magnetic field inside the coil is perpendicular to the plane outward. Now, here if the direction of current is clockwise, then the magnetic field at the center is perpendicular to the plane of the paper if you have drawn into the paper, and inward. So, that is represented by this one, or you can say magnetic field is going into the plane of the paper, and here the magnetic field is emerging out of the plane of the paper. Similarly, we can say also here show the direction of the current. We can take the direction of current by this way. If the current is suppose emerging out of the plane of the paper, then magnetic field lines are anti-clockwise, and if the current is going into the plane of the paper, then the direction of the magnetic field is lines are the clockwise. So, this is about the magnetic field around the current carrying conductor, or you can say here the current carrying conductor, if there, then also it has magnetic field, and by this way we can define the directions, and this is the introductory part of this chapter here. So, first we must know how to depict the direction of the magnetic field.